So welcome to 523 or 532 and 533 for Faster Way. This is going to be for January 2nd and January 3rd while I'm done for both my B and geometry. So again, this is going to be kind of a quick up and down way to kind of show you how to get some specific values for the law of sine and cosine. So we've talked about how we can use sine, cosine, and tangent now pretty extensively for the past couple of weeks, all the way back in December, and then obviously now we're going to be kind of talking about in January up until semester exams. So the way that we've kind of talked about using trig functions is you've had to have a right triangle in order to do so. Now, some of you may realize that obviously some triangles aren't always right triangles. So does that actually apply for the idea of law of sines and the law of cosine, or excuse me, the trig functions for sine, cosine, and tangent? Well, here's the wonderful thing about this. The law of sines and the law of cosines allows us to solve for specific values of both angles and the specific value of the side length given just a specific not right triangle. So as you can see, these two triangles here with the sines and law of cosines are not right. So in other words, if we want to use the law of sines, here's the formula to do so. So the formula goes sine A, or use a capital letter A, over the value of sine A, and we're going to go smaller A. Actually, in this case, it should be A, excuse me. So in this case, it's just going to be sine A over A is equivalent to the value of sine B over B. So, in other words, what these all stand for is a specific part of the different triangle. So, in other words, A is an angle. So, in other words, A stands for the angle, and the small a stands for the representation of the side. So, in other words, A and A are like the values of 45, 45, 90 triangle. We're talking about special right triangles. In this case, the angle corresponds with the value of the opposite side, just like we would use if it was a right triangle. The same kind of idea for B. So in this case, I have the uppercase B, and then I can also have the lowercase b. Okay, so B again is just the angle, it's just a notation, and then small case b is the corresponding side with it. So the nice thing about law of sines is basically you can solve for either the missing side length or the missing angle, depending on what you're given in terms of the angle. In this case, if you have the corresponding angle and the opposite side length, then you can solve for that specific part of the triangle. It's the angle or the actual side length. So, kind of a unique way to solve for it, again, especially. So, it all kind of comes from the idea of Pythagorean theorem and using trig functions, but in this case, again, the proof gets a little long. If you want to look up on YouTube, it's kind of cool to always see it. So, the law of cosines is very similar, but a little bit different. So the law of cosines is the function that looks kind of something like this, and I'll put it in a different color so it's easier for you to see. So in this case, the law of cosines is c squared then equal to a squared plus b squared. So as you can tell, this is kind of like the Pythagorean exactly like the Pythagorean theorem, and then minus 2a cosine, and then the big letter c. So law of cosines is a little bit different than sine because in this case, the formula is not so rigid in terms of it means that it's a side length and such. But what you're going to see is C right here stands for a side length as well. So in other words, we have that side length. What we're doing here is we're trying to find that missing side length of the actual function. You can also use this to find, again, the missing angle as well, but it's not as useful as, say, sine. So in other words, if we have C, this would be like the small, excuse me, this would be like the big letter C, so you're getting an angle here. So you can make it like 40 degrees or something. And then if you look at the opposite side length, obviously that's going to be the small letter C. So again, big C and then small c, because again, you need the corresponding side. And then the same kind of idea for obviously the angle. So in this case, angle is going to be like a big letter A, but you don't even have to write it. So all you need is just A. And then again, the other angle, but in this case, you only need is B. So the nice thing about it is cosine, if you have two missing side lengths and then the corresponding value of the angle for the side length you're trying to find. So in this case, if it was C, You need that angle right there. You can go ahead and solve for that missing side length without having to use sine, cosine, or tangent. So in this case, these two formulas are going to be really useful come a couple of different problems when we kind of roll into chapter 6. So what we're going to do is we're going to kind of put this to practice, and then you can kind of use this as fit. The nice thing about this is it requires very minimal math. All it takes is for you just to know where to plug in values, and then once you get done so, all you need to do is just plug in the calculator. So in this case, for 583, it says, is there a relation between the triangle sides and the angle opposite of it? And for example, assume that the diagram of the triangle ABC shown below is not drawn to scale based on the angle measurements provided in the diagram. Which side must be the longest? So if we look at the sides, what must be the longest and what must be the shortest? Well, let's think about this for a second. If we know this is 105 and we know that this is 63, what I'm going to do is I'm going to go ahead and add this to the triangle sum theorem that we've used in the past. And if we remember triangle sum theorem, we know that it adds up to 180. So I'm going to go ahead and do 180 minus 105, get a value. That's 75, and then minus 63, which in this case then becomes a value of 12. So this is the same kind of idea as we've talked about in the past. So if I'm looking here, what I'm looking at is the idea of actually using sine, cosine, or tangent. But in this case, I don't have the right angle. What I'm going to do is I'm going to actually find which one actually has the shortest side length. So it would make sense that if we have an angle measure that is smaller, then obviously the side length is probably going to be shorter as well. So the shortest side length, in this case, if I draw it to my shortest angle, the opposite side length is going to be AC. So AC is the shortest side. All right, so as you can see, what you end up having there is you have ACD in the shortest side length, whatever that value is, because again, in this case, it's also, it has the smallest angle associated with it. Now, the large one, as you can probably guess, in this case, is going to be the 105, because if I draw an arrow to that one is going to have the longest angle, or excuse me, the greatest angle within the triangle. So therefore, if I look, the side BC is the longest side. And this again all stems from the idea of the Pythagorean theorem and using the idea of sine, cosine, and tangent. Now, when we have this, what we're going to do is going to go ahead and roll down to 584. So it says, when Madeline examined the triangle below, she said, I don't think this diagram is drawn to scale because I think the side labeled x must be longer than 4. So in this case, do you agree with Madeline? Yes, why or why not? So again, hopefully using the idea of law of sines and law of cosines, hopefully you figured out that this is such the case. And the reason why is because Madeline is looking at the idea of this value, 26 degrees, and this idea of 42 degrees. So in other words, when we have that 42 degrees, obviously that is going to be a little bit longer than the value of the 26 degree opposite side length. So in this case, I always draw to the opposite side length. And I do the same for the value of 42 as well. So what we're going to do is we're going to end up finding x. So therefore, do we agree with Madeline? Yes, because it has a greater angle. Nope, it has a greater angle. Okay. Now, it says Lila thinks that x can be found by using right triangles. Review what you learned in 5.31 by finding the value of x. Now, if we wanted to, what we could do is we could go ahead and split this triangle down the middle, make a right angle, and then try to find the value of x. Now, in this case, what we could end up doing is we could end up finding x. What we'd have to do is we'd have to use the opposite side length. So we would make this thing like y. And then what we end up doing is we do opposite over hypotenuse, use the sine function, get that value of y. And then what we could end up doing is we could use, again, sine again. So sine opposite over hypotenuse and get that value there. Now, that's kind of a long, arduous process. What I'm going to do is I'm going to try to find x by just using what we call the law of sines. Now, the law of sines is a ratio. So what we have here, if we look, is we also have the law of sines with the opposite angle, excuse me, the angle and the opposite side length, and then the angle and then that opposite side length. So if I look, what I'm going to do is I'm going to go ahead and plug those into the ratio start. So again, the idea, sine, and then the angle over the corresponding side equal to sine, and then the other angle with its corresponding side. So what I'm going to do, I'm going to pick one of them and plug it in. It doesn't matter which one goes where, as long as, again, you have the associated, corresponding side length and the angle. So therefore, first one, I'm going to do sine and then a. So therefore, I'm going to go ahead and pick 26 for this one. So I'm going to do sine of 26 over the value of, in this case, sine, or excuse me, 26 over the value of 4. So therefore, I have sine of 26 over the value of 4. Then what I'm going to do is I'm going to go ahead and plug in the next one. So therefore, if I look, I'm going to have sine of 42 over the value. Now, this is where it gets interesting because in this case, I don't have a value there that's associated with it. So now, here's the fun part about this. Now, when we solve this, what we're going to do is, if you look, we have an equal sign with two different fractions. And the wonderful part about this is, just like we solved the sine, cosine, and tangent, we end up cross-multiplying in order to find this value. So in this case, I'm going to go ahead and do x times sine of 26, and then 4 times sine of 42. And you're going to see how these work now. So in this case, I have x multiplied by sine of 60, or sine of 26. So now I'm going to write them together and multiply. And then equal to the idea of 4 times sine of 42. Now, this looks like a whole big mess, and you're like, oh, this doesn't look good. Well, have no fear, because if I look, what I'm going to do to get x alone, I want to solve for that missing side length. I'm going to go ahead and divide by the value of sine of 26. So, in other words, what I'm going to do is I'm going to divide by sine of 26. We know from previous problems that that cancels out. That's going to become a triangle 1. And then I'm going to do it on the other side, because anything I do to one side, I do to the other. I'm going to go ahead and put sine of 26 there. So as you can see, what ends up happening is we end up getting a ratio that we can go ahead and just plug in our calculator, which is really, really nice. So in this case, what I'm going to do is I'm going to go ahead and take my handy dandy calculator, and I'm going to go ahead and plug in those values. So the first one, I'm going to go ahead and do 4, and then the sign button, and then the value of 42. Very important, make sure that you close this parenthesis right here, because otherwise what's going to end up happening is you're going to end up dividing the 42 with the sine of 26 within the other sine function. So in this case, you don't want to do that, because again, that sine 42 is the angle that's associated with that missing side. So therefore, we divide then by the value of sine of 26. Close that up. And then what we do is we hit the enter button. And out pops, in this case, the value for the value of x. So, which is really cool, because in this case, what we end up having to do is we end up just getting the value for the actual height. So therefore, x is equal to, in this case, about 6.1 for that value. Okay, so that's how we find the law of sines, which I think is kind of cool, because in this case, no longer do you need a right triangle to actually solve for this. You can actually now use that idea to solve for the value. Now, to get the area, in this case, again, you would just use that idea, base times height divided by 2, and you could be able to solve for it as well. So in this case, again, if you want to do so, feel free. I'm not going to worry about it, because, again, it's not that important to find the area of triangle. You know how to do that. We don't want to worry about the law of sine and cosines. All right, so now we got the front side. We're going to go ahead and flip on the back. Okay, so now what we're going to do is we're going to take those same kind of ideas. We're going to go ahead and try to solve for a couple of specific values. So in this case, what it's asking us to do for 586 is it's asking us to solve for the value of x. And this one, again, as you can see, is going to be plugging in with the value. So how we do this, in this case for that problem, is we're going to go ahead and take a look at what we know. What we end up having here is we end up having the value of 28 degrees. We're going to have the value of 120. And then we're going to have the value of 10 and x. So therefore, if I'm looking, again, we can use the same kind of idea, law of sines. So therefore, I'm going to go ahead and draw my angle to my opposite side length. Kind of tricky here, because again, it's kind of close to the value of 120, but in this case, it's 10. And then the other side length, if I draw to the opposite one, that's going to be the value of x. So right here, this is where I know I'm going to use the law of sines in order to solve for this, because in this case, again, I have no right angle, so therefore I can't use sine, cosine, or tangent. The law of sines, again, states the following. sine of value of A over the short side, or in this case, again, whatever side you choose, and then sine of the angle B with the other corresponding side. So now what we're going to do is we're going to go ahead and simplify for this result. So we're going to go ahead and plug it in. Feel free to pause this video. In this case, again, try to solve it. If you need some extra practice, by all means, again, keep watching, so that way we can kind of work together and solve it. So what I'm going to do is I'm going to go ahead and plug these values in for the law of sine. So therefore, I'm going to go ahead and take a look. So sine A, I can choose either angle. I'm going to go sine of 120 here over the value of. In this case, again, I'm going to have that x value, so therefore I'm going to put x over it, because again, that's my opposite side length, or corresponding value of the angle, equal to the idea of sine, and that is 28 over the value of 10. So now I have this function right here. So again, same kind of idea. I'm going to go ahead and cross multiply, just like I did with the previous problem. The wonderful thing about this, again, is it all kind of acts the same. So we're always going to cross multiply, just like we did sine, cosine, and tangent for this value. So we're going to cross multiply, go bada bing, bada boom, we will multiply. So in this case, we do x times sine of 28. That's going to equal the value of 10 times sine of 120. Okay, so now, as you can see, we end up getting the same kind of problem we did from the previous one. We're going to go ahead and divide. So therefore, I'm going to divide by sine of 28. And I'm going to divide by the other side of sine of 28. So now what's going to end up happening is you're going to end up getting the values that are going to cancel out. So therefore, sine of 28 crosses out here. And then we get x is equal to, and then the remaining values that you can plug in. So therefore, bring it back your calculator. I'm going to go ahead and clear it, and I'm going to go ahead and plug it in. 10 sine 120, close that up, and then divide by sine of 28. So now, as you can see, we're going to go ahead and hit enter, and we're going to get our value. So in this case, roughly about 18.44 degrees, or excuse me, degrees, I should say feet there. So in this case, label feet. If you want to look it up, you can do 4.5 there. I should say 4.5 and feet. Now, you may ask yourself, how do we know if this value is actually correct? Well, if we look at this problem from like a lens of the idea of what we know about triangles, remember we talked about if the angle is smaller, the idea is that 10 should be smaller as well, compared to the idea that 120 degrees, in this case, has a greater side length. So in other words, if we know this is 10, I'm looking at this value and saying, okay, does this one make sense? In this case, 28 is a lot smaller than 120. In this case, we end up getting a value of about 18.45. So in this case, that's greater than 10. That seems like a pretty good idea that we did it correctly. Okay, so that kind of checks out. All right, so the last problem that I'm going to have you do here today, I'm going to go ahead and kind of bring this all back together one more time. In this case, is going to be the law of cosines. Once I'm done with this problem, I'm going to be kind of done for the day. So I'll kind of bring a new video for you. This will be kind of like the second part of it, so you can kind of work on your homework for these kind of problems. And then we can kind of go from there. So again, this will be like the end of Thursday, and then we'll kind of pick up where we did for Friday and finish up with these kind of 4 examples here. So in this case, the problem here from 596A is asking you to find the x value. Now, the x value is a little bit different because if I look really closely, I'm given obviously the angle of 120 degrees here. And I have the opposite x value, so it's like, good, we're good to go, right? We're going to use law of sines. But if we look closer, obviously we have this angle and we have this angle. And obviously we could try to use the idea of triangle sum theorem and do 180 minus 120, but we don't know that these are congruent angles. We don't know what values they could be. So this kind of leaves us stuck between a rock and a hard place. So law of sines is probably not the best one to go here because in this case, what you need with law of sines is you obviously need 2 angles in their corresponding sides. So in this case, one corresponding side is we've been solving the past couple. So 596A, we're not going to end up using actually law of sines at all. What we're going to end up using is actually the one that we just talked about previously, which is in this case is the law of cosines. The law of cosines, again, is very similar to law of sines, but in this case, it allows us to solve for something that might not be there. And the idea is when you have the law of cosines, remember, it's the idea that you have the two side lengths that are not with the corresponding angle. In this case, C was the one we chose here. And we also have, again, the value for the angle for C, but we're solving for that missing side length there. And as you can see from the back side, what we have is we have the exact setup for this. So we have A and B, so those are the two side lengths. We have the missing side length, and we have the corresponding angle associated with that missing side length. So what we're going to do is we're going to go ahead and plug this all in order to solve for it. So the wonderful thing about the law of cosines, obviously, is it's a pretty long formula, as you can see, but it's very similar to the ones that you've done in the past. C squared is equal to A squared plus B squared. That's Pythagorean theorem. But the only other part you got to remember is minus 2AB and then cosine C. So what we're going to do is we're going to go ahead and plug this in, okay, their corresponding parts into the values. Now, what I'm going to do is I'm going to start with C squared. You can write x squared, you can write c squared. I'll just plug it in as x because in this case, again, that's the formula that we have and the variable we're solving for. In this case, a and b, it doesn't matter which value you choose. I can make 6a, I can make 7a. It doesn't matter. So therefore, I'm just going to start with 6. So therefore, I'm going to do 6 quantity squared plus 7 quantity squared minus 2 times the value of 6 times the value of 7. And then I'm going to write cosine and then the value of 120. Now, some of you are panicking right now because you're like, how the heck are we going to solve all this? Well, folks, what I'm going to tell you is don't. You don't need to solve all this. What you need to do is you need to have a calculator and know how to put it in. So what you're going to do is you're going to write x squared underneath the left-hand side. And then what you're going to do is you're going to go ahead and plug this all in to your calculator. And here's how you're going to do this. The calculator, again, is a really nice tool to help you solve for the missing values. So when we do that, what we're going to do is we're going to go ahead and plug this in. So the first thing I'm going to start with is obviously the x squared is going to stay. I'm going to go ahead and hit 6 quantity squared plus 7 quantity squared. And then what I'm going to do is I'm going to hit the minus button. In this case, you can hit either the minus button down at the bottom here, or you can hit the negative one down here. It doesn't really matter. I'm going to go ahead and just hit minus 2. And I'm going to multiply by the value of 6. So I'm going to put that as in parentheses. And then put that in parentheses as well. So the value of 7. And then finally, I'm going to hit the cosine value. And then 120 and close up shop. So plug this all in. I'm going to go ahead and hit this value. Now, it comes out to a value of 2094. In this case, sometimes the value, again, will be a decimal. Sometimes it will give you a whole number. But again, it's important to keep this all in your calculator. And here's why. Because in this case, we want the value to be as close as we can. So pretending like this was a decimal. Obviously, it's not. But in this case, what I'm going to go ahead and do is I'm going to go ahead and keep that answer within my calculator because it's already saved. And here's how I'm going to do this. Obviously, to figure out x, we need to go ahead and take the square root for our last step. So we're going to take that square root from both sides. So I'm going to get the value of x. In this case, what I'm going to do is I'm going to go ahead and take that square root of the answer. And here's how I'm going to do this. So I'm going to go ahead and clear this out. So everything's blank again. But now what I'm going to go ahead and do is I'm going to go ahead and hit the second button. And obviously, I need to take the square root. So I'm going to go ahead and hit the square button. So there's my square root. And then what I'm going to do is I'm going to do another second. But now what I'm going to do is I'm going to go ahead all the way down at the end of the button. In this case, all calculators have this thing called ANS. What that means is it's the answer. So the calculator stores the previous problem from the one that you calculated. So the nice thing is I'm going to go ahead and put that answer that I just calculated from the value, in this case that was 2094, into the calculator. Now, obviously, again, as you probably can see, we can go ahead and just do 2094. We're good. But in this case, again, if we have a really long decimal, this keeps all the values in there from the previous problem that we inputted. So therefore, I'm going to go ahead and close it up. And I'm going to hit the second button, answer, and I'm going to hit enter. And as you can see now, it takes the square root of the value of 2094, which in this case is about 45 point and then 76. Since it's not asking us to round to any specific value, I'm just going to keep it as the 100%. So 45.76. So as you can see, the law of cosines is actually very easy. You just go ahead and plug in the values from the formula, and then what you do, you're just keeping them in your calculator, and then you can solve for them just like that. The hardest part with law of sines and cosines is being able to determine which one is which. So in this case, again, we kind of talked about them a little bit more. And as you practice, you go along, you're going to be able to kind of get better at them. And you're going to be able to solve them a lot easier. So in this case, again, just to prove to you that this actually does work, that answer, I'm just going to do the square root of 2094. There we go. And you end up getting the same value. So again, wonderful part about your calculator, again, it's very handy when it comes to all these different values. All right, so this is 532 and 533, solving law of sines and cosines. As you can see, we still have a couple more problems that we're going to go ahead and hit tomorrow. In this case, again, please make sure that you're being respectful for the sub while I'm gone. I really do appreciate it, folks. When you come back the following Monday, in this case, it's going to be I believe, seventh, if I recall. So in this case, again, we're going to have like five. We're going to get more practice with this, with law of sine and cosine, and you're going to end up having a quiz on that day as well. So I think it'll be like C hour on Monday and then B hour on Tuesday. So again, if you're struggling with this, we're going to be like going over this all on Monday, just to make sure that you kind of got it all down, and Tuesday as well. And that way you can kind of come to any questions that you might have. Okay, this is the last part of chapter 5. In this case, again, when we come back, obviously we'll only have that one whole week, and then we'll be back with 2 more days, and then it's semester exams, as crazy as it may sound. So please make sure that you're getting ready to go, especially for this next couple of weeks. It's going to be very important for your grade. You got your chapter test and the semester exam all in one, so make sure that you're ready to roll, and we can go ahead and answer any questions as possible. So I hope you had a great restful winter break. I'm looking forward to seeing you all when I get back January 7th. So please make sure that you're doing your best, and we'll look forward to you, and we'll see you all tomorrow. Have a nice day.